thin garden hose. So I think he's about to give an analogy. I'm not sure exactly what he'll do. Keep the fish example in mind. I think that one is pretty good at trying to explain how there may be more dimensions, but we'll see what Brian Greene does with his garden hose example. Imagine that a few hundred feet of garden hose is stretched across a canyon, and you view it from, say, a quarter of a mile away. From this distance, you will easily perceive the long, unfurled, horizontal extent of the hose, but unless you have uncanny eyesight, the thickness of the hose will be difficult to discern. From your distant vantage point, you would think that if an ant were constrained to live on the hose, it would have only one dimension in which to walk, the left-right dimension along the hose's length. If someone asked you to specify where the ant was at a given moment, you would need to give only one piece of data. So one piece of data means 1D. 2 pieces of data means 2D. 3 pieces of data means 3D. 4 pieces of data means 4D. In this case, 1 piece of data, according to us, for the ant. The distance of the ant from the left or the right end of the hose would suffice in order to say where it is, and it would be like a 1D answer. The upshot is that from a quarter of a mile away, a long piece of garden hose appears to be a one-dimensional object. In reality, we know that the garden hose does have a thickness. You might have trouble resolving this from a quarter mile, but by using a pair of binoculars, you can zoom in on the hose and observe its girth directly. From this magnified perspective, you see that a little ant living on the hose actually has 2 independent directions in which it can walk. An ant has more options than we knew. It actually has 2 dimensions that it can traverse. So the same thing might be the case for us, where we experience 4D, but actually there is more dimensions that we just don't experience or don't see because we're not zoomed in enough. Okay? You now realize that to specify where the tiny ant is at any given instant, you must actually give 2 pieces of data: where the ant is along the length of the hose and where the ant is along its circular girth. This reflects the fact the surface of the garden hose is 2-dimensional. Nonetheless, there is a clear difference between these 2 dimensions. The direction along the length of the hose is long, extended, and easily visible. So we can easily see the one-dimensional, the length dimension. We cannot easily see the circular dimension, but that doesn't mean that the circular dimension does not exist. Similarly, it could be that there are extra dimensions that we are not zoomed in enough to see that exist, and we just can't experience them. Okay? The direction circling around the thickness of the hose is short, curled up, and harder to see. To become aware of the circular dimension, you have to examine the hose with significantly greater precision. Similar to this, there might be curled up little other dimensions that we don't experience, but we would have to be significantly more precisely observing things in order to acknowledge them, see them, measure them, etc. I mean, so far I don't think we have seen the curled up extra dimensions of string theory, but that's what the author is trying to make the point for. This example underscores a subtle and important feature of spatial dimensions. They come in 2 varieties. They can be large, extended, and therefore directly manifest, or they can be small, curled up, and much more difficult to detect. Of course, in this example, you did not have to exert a great deal of effort to reveal the curled up dimension encircling the thickness of the hose. You merely had to use a pair of binoculars. However, if you have a very thin garden hose, as thin as a hair or a capillary,